Alright, here we have lecture 2.7, which corresponds with section 3.4 from the textbook. And it's here we'll be opening it with algebra of functions, but really focusing on composition of functions. So what I mean by algebra of functions is addition, subtraction, multiplication, and division of functions. It turns out functions are closed over all of these operations. So what that means is if I add two functions together, I get a third new function. If I subtract two functions, I get a third new function. And multiplication of functions creates a new function, and division of functions creates a new function. Let's go ahead and look at an example here. We got f plus g at 3. Now remember, a function is input, output. So what this actually equals is f at 3 plus g at 3. And then we can evaluate each. F at 3 is going to be 1/5. G at 3 is going to be 2 over 2. Alright, just plugging 3 into the functions f and g, which are defined in the directions there. And so that gets us 6/5. Or if you want to write that as a mixed number, that would be 1 and 1/5. Alright. Now you can also evaluate this with a variable input. So g minus f at x is going to be g at x minus f at x. Note the order matters here. So g at x is 2 over x minus 1 minus f at x, which is 1 over x plus 2. Now, a word of warning here, I cannot stress this. We are not solving an equation. This was not an equation. We are simplifying and evaluating. That's what we're doing here. So we cannot clear the fractions. We do need a common denominator. So to subtract fractions, you need a common denominator. So this denominator is missing a factor of x plus 2. The second denominator is missing a factor of x minus 1. So when we subtract those, we have 2 times the quantity x plus 2 minus 1 times the quantity x minus 1 all over that common denominator, which is going to be 2x plus 4 minus x plus 1 all over the common denominator. So once we're all done simplifying, we get x plus 5 over that common denominator. Again, when we're simplifying, we cannot clear the fractions. We do not have that degree of freedom. Alright, let's look at one more example. F divided by g at x, so that's going to be f at x divided by g at x. So f at x, let me look back at the directions on the last page, is 1 over x plus 2 divided by x squared. So remember, division by fractions. To divide fractions, you multiply by the reciprocal. So division by x squared is the same thing as multiplication by 1 over x squared. And there we have it. So the main thing there is just remembering your fraction rules. Let us now discuss composition of functions. So given two functions f and g, their composite function is defined as follows. Note that little open dot denotes composition is not the letter O, and it reads from left to right. So f composed with g equals f of g at x. So you want to work from the inside out. Let's go ahead and look at an example here. So you read from left to right. So we have f at g at 5. And we're going to work from the inside out. So we're going to ignore f for now. We're going to evaluate g at 5. So I take 5, I put it in the function g. Alright, so that's going to be square root of 5 minus 1. Putting it in the function g, and we get 2. And then we put that into f, and we get 7. All done. Alright, now let's try the reverse and see if we get the same thing. Instead of doing f composed with g, let's do g composed with f at input 5. So again, we'll work from the inside out. So f at 5, we want to do that first. F at 5, that's 5 squared plus 3. So that's g at 28, which equals square root of 27, which reduces to 3 root 3. And as you can see, order matters. And we can do this with a variable too. So let's go ahead and look at this example number 3. So that'd be f at g at x. Again, working from the inside out. So I've got to flip back. G at x is square root of x minus 1. So we take that, punch it in. So that's going to be square root of x minus 1, quantity squared, plus 3. The squaring will cancel the square root, and that simplifies down to x plus 2. So if I wanted to evaluate this, if you're clever, you won't go through the whole composition process. You realize we actually just figured out this function back in example number 3. It's just going to be 99 plus 2. So we've already done all the work behind the scenes. This is going to be 101. And if you're not sure about that, well, you can practice it. You know, if you want to do it separately, we can view that as f at g at 99. Okay, well, g at 99, that's going to be what? Square root of 98. Well, then you square that and add 3, and you get 101. The same exact thing we had before. So that's why it pays to evaluate with a variable. Right? If you can figure out what the simplified function value is with just the variable, then evaluating it with a constant will be far easier. Just keep in mind order matters. All right, and we're done with that section and off to the very last section.